Okay, today we're going to learn about specific heat capacity. We're going to learn what specific heat capacity actually means. We're going to have a look at the equation to do with specific heat capacity, and we're going to have a look at an experiment in order to find the specific heat capacity of a liquid. So let's just imagine this. Let's say I have got two substances here. This first one here is water, and this substance here is liquid, well, mercury, which is a metal, but it's liquid at room temperature. Let's say I've got a kilogram of each of them. So what specific heat capacity actually means is how much thermal energy is required in order to raise 1 kilogram of this by 1 degree Celsius. Now what that means is this. Let's say I'm applying thermal energy to both of these, so I'm heating both of these up. Now, because these substances are different substances from each other, they're going to take a different amount of thermal energy in order to raise the temperature by 1 degree Celsius. So water would actually require 4,200 joules of thermal energy, whereas mercury would only require 139 joules in order to raise that kilogram by 1 degree Celsius. So that is essentially what specific heat capacity actually means. How much thermal energy is required to raise 1 kilogram of that substance by 1 degree Celsius. And every different substance will have a different specific heat capacity. Now there's an equation that we need to be able to know and use in order to determine specific heat capacity. So the change in thermal energy equals the mass, so that's the mass of the liquid that we're dealing with, times the specific heat capacity, that's the thing we may well be looking for, times the temperature change, so how much the temperature has risen by. So what we're going to do now is we're going to have a look at an experiment that we could do in order to find the specific heat capacity of a liquid. So let's say I've got, the first thing I need to do is I get my container and I'm going to put it on an electronic balance. So let's say at the beginning my electronic balance, it reads 100 grams. So that's without the substance in it. So that's, my electronic balance says that weighs, that has a mass of 100 grams. So what I'm going to do next is I add my substance, so my liquid, and let's say now this has a mass of 150 grams. So in order to find the mass of just this liquid here, what I'm going to do is I'm going to do 150 minus 100, which gives me an answer of 50 grams, okay? So that's my first step. What I'm then going to do is I take my container, because I'm going to do this experiment to find the specific heat capacity of this particular substance. So what I need to do is I'm going to put a lid over the top of it to prevent heat loss by convection. I'm also going to have a thermometer in there, because this thermometer is going to read my temperature change. And I'm also going to be using this thing called a Joule Meter. So what my Joule Meter is doing is my Joule Meter is actually connected to an electric immersion heater. So all it is this heater which goes into the liquid, and then I'll be able to, on my Joule Meter, see how much thermal energy has gone into this immersion heater here, okay? So, for my experiment, what I need to do is I need to pick a sensible temperature rise to look at. So let's say 10 degrees Celsius would be a sensible amount of a sensible temperature change. So what I need to do is I allow my temperature change to 10 degrees Celsius, and then on my Joule Meter I read how many joules it's taken in order to raise that by 10 degrees Celsius. So let's say, for sake of argument, it took 1,000 joules to raise this liquid by 10 degrees C. So now I've got everything that I need in order to try and find the specific heat capacity of this substance. So what I'm going to do is I'm just going to write down these different parts. So first of all, my change in thermal energy, well, that there is on my Joule meter. So it's 1,000 joules. So that equals the mass. Now my mass is the mass of this liquid here, but please notice that needs to be in kilograms, whereas on my balance it may well have read it in grams. So to divide from grams to kilograms, I need to divide by 1,000. So in this case, it's 0.05 kilograms. So it's 1,000 equals 0.05 times by C. That's my specific heat capacity. That's the thing I'm looking to try and find. And finally, multiplied by my temperature change. And my temperature change is the one that I chose, which is 10. So what I need to do now is I need to get C all by itself. Because if I can rearrange this equation, to make C the subject, then I'm laughing. So what I'm going to do first of all is I'm just going to simplify it. So I've got 1,000 here. I'm going to multiply these two numbers together to begin with to make it easier. So 1,000 equals 0.5 times C. All I've done is multiplied those two numbers together. Now I still haven't got C but all by itself. So what I'm going to do is I need to make sure I do the same thing to both sides of the equation. I'm going to divide this side by 0.5, because at the moment it's times by 0.5, and I'm going to divide this side by 0.5. So let's just have a look. 1,000 divided by 0.5 equals 2,000. So that is my specific heat capacity of this substance. Just going to rewrite like this. So C equals 2,000. Now specific heat capacity has a bit of a strange unit. It's joules per kilogram degrees Celsius. So that is the specific heat capacity of this particular substance. So just to recap, specific heat capacity is the thermal energy required in order to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. This is the equipment that you need in order to find the specific heat capacity of a substance. Here is the equation for specific heat capacity, and this is how you use the numbers from your experiment in order to determine it. Thank you very much.